Hello, lower school. I'm going to go through the first exploration of the text here, the lesson openers as well. This will be really helpful to you if you were stuck on some. If you've already finished, which a lot of you already have, that's great. You can check your answers with mine. You can just pop this video into half your screen or watch this video on your phone while you check your answers on your packet or check your answers on a computer screen. It was really good to hear from so many of you, and it was also really good to see that you guys kind of checked in at the desk and that everybody seems to be healthy and that most of you, I think all of you so far that I've heard from, have internet access. So that's going to make the learning really fun, even though that we have to be away from each other for a while. So let's jump right into it. The chapter we're reading is called How Does Gravity Affect Matter on Earth? Take a look at this picture here. These are stars, many different stars here. Really cool picture of the Earth. And as you notice, the Earth is in fact round. Earth's curved shape is easily seen from space. When standing on Earth, it is difficult to know you are living on a sphere. So that kind of pops up all that flat Earth stuff, is that when I walk outside, it feels pretty flat. But if you look at it from a distance, the Earth is very big and very round. Our planet Earth is constantly moving. The continents and all people living on them are spread out across Earth's surface. Select each country to learn more about some places on Earth. So it says here, Iceland. Here is a family hiking in Iceland. Iceland is an island north of the equator, between North America and Europe. It is in the northern hemisphere, or the northern half of the Earth. So right here, this half is the northern hemisphere. China. Here is a family playing in China. China lies north of the equator in Earth's northern hemisphere on the continent of Asia. This is a family in Argentina. Argentina lies south of the equator in the southern hemisphere, or the southern half of Earth. It is on the continent of South America. So when you're looking at this question, you might say, what do you think keeps all the people and other things on Earth's surface from falling off? Enter your answer in the space below. This is a really interesting question. How do people on the southern hemisphere not fall off the Earth? I thought gravity pulls us down. Actually, gravity pulls us towards the center. So, short answer here for these lesson openers is the reason people do not fall off. I took a look at some of your answers. A lot of you had that right idea, and knew gravity had something to do with this. Gravity. When we are on Earth, there you go. Then we go next. Okay, I'm just going to cover exploration 1 today. Tomorrow I'll be back to go over exploration 2. And what do you know? Maybe one day I'll become this big YouTube teaching star, and you guys are going to be my fans that help me go viral. So where does the sun go? Thousands of years ago, people believed the Earth was flat because that is how it looks when you are standing on it. Watch the video to learn more about the movement of the sun across the sky each day. Now, I'm going to try and make it so that you can hear the video. Doesn't seem like I can do that. I'm going to play the video and see what happens. Basically, so see how each day it changes the day when the sun comes up for the day. And then it goes away and comes back, and that is why we have days. So if you lived at that time, the time where they thought the Earth was flat, you would have noticed that the sun rises in the east, goes overhead during the day, and sets in the west at night. You might have wondered how the sun could have ever returned to the east by next morning. How do you think people who believed in a flat Earth would have explained the sun's motion at night? Select the best answer. So what do we think here? Let's go ahead and just check our answer. It traveled underneath the flat Earth each night. Okay, Okay, so try this activity. It says start with a golf ball, hold the ball 15 centimeters from your face. As you hold the ball, notice its shape, keeping yourself and the ball still. So 15 centimeters is not very far. Repeat these steps with a basketball, then a large beach ball. Draw what you see in the boxes below. So I'm going to do my best here with the mouse. So if you hold the golf ball 15 centimeters from your face, you'll probably be able to see maybe even like the full golf ball. So something that looks like that. If you hold the basketball 15 minutes in front of your face, you'd probably see something that looks like this. Okay. You might be able to see the edges of it. And then if you see the beach ball, which is much bigger, you might only be able to see the beach ball and nothing behind it. So something like that. Okay. How is your view of each ball's shape affected by the ball's size? So the small golf ball looked the flattest. Well, to me, that looks the roundest. The very large beach ball looked the flattest. Yeah, it kind of just looks like a flat piece of paper right in front of your face. The large basketball looked the roundest. The very large beach ball looked the roundest. I think it's B. So if you look at this ant here, if it looks out, it can only really see the beach ball. So it might think that it's flat. Okay. The ant might never see like this actual curve here, but because we're humans and we look at a beach ball, we see the full picture of it. That's basically why a lot of people think the Earth is flat or used to think the Earth is flat. Okay. So we're going to keep going. How does the ball activity help you explain why Earth looks flat to us? Select all answers that apply. The larger the ball was, the more flat it looked. That seems true to me. The Earth is very large, so it could appear flat to us. Sounds good. The Earth looks small when you are standing on it. No, the Earth does not look small when we're standing on it. So we have all seen images of a round Earth from space. Are there ways to tell Earth is curved while standing on it? Watch these videos to discover more about Earth's shape. So I'm going to play this, and the videos have closed captions, but I'll also help explain some things. So we can prove that the Earth is round when we're standing on it. And here's a couple ways. So as Mario goes up and up and up, the view of the horizon changes slightly. So that's a really cool little experiment. Here's another. So what you see is sailing towards us. Okay, I think you guys can answer that question. So basically, it's because the Earth is round. So up in this Ferris wheel, we can see the horizon because the Earth is curved and the horizon is hidden behind the curvature of the Earth. Same, the boat is hidden right now behind the curvature of the Earth. Okay, so this is a cool diagram. Think about the video showing the ship sailing towards you. Use the images here to support what you saw in the video. Select the best answers to complete the statement below. So here's the ship sailing on a curved Earth. And like you said, like I can only see the tip of the ship here. If the Earth was flat, I'd be able to see the whole ship the whole time. If the Earth were round, you would be able to see only the top of the boat as it sailed over the horizon line. Now look at the bottom image. If the Earth were flat, you would be able to see the whole boat. In the video, we saw only part of the boat at first. Earth must be round based on evidence. So think about the video showing the boy on the Ferris wheel. Use the images below to support what you saw and help prove Earth's shape. Select the best answers to complete the statement below. So here is a flat Earth, a person standing on the ground, a person standing up high. Notice that they both can kind of see the same exact part of the building. Whereas on a curved Earth, the person down low can only see the top of the building. The person up high could see, actually the person down low can't see any of the building. The person up high can see the very top of it. The flat Earth diagram shows that both people would be able to see the building no matter where the person was standing. So as you can see right here. In the curved Earth diagram, the person at the top of the tower can see the building, but the person on the ground cannot. So that's what these little triangles are. They show their field of view. So this person can't see it. This person can. The boy on the Ferris wheel only saw the distant city when he was up high. If the Earth were flat, the boy would have seen the city when he was on the ground too. So we're going to do some math. Elevation is the height above Earth's surface. The data in the table shows how much of Earth's surface you can see from different elevations. Study the data, then use the graphing tool that follows to show how these data appear as a bar graph. Notice how data can be represented in a table or a graph. So let's see, elevation 1, 3.5. So I just take this right up to 3.5. And if you're doing this on a hard copy, you just use a pencil. 100 meters would be 35.5, I think. Yep, 35.5. The next one was 200 meters, 50.5. 50. There we go. And 300 meters was 62. 400 meters was 71.5. And 500 meters was 80. You guys are probably cheering me on at home right now. You can do it, Mr. Girl. I got it. Almost. Come on. Won't let me do 80. Interesting. I'm going to keep it there. You can see more of Earth's surface the higher you are. It's because you can see over the clouds? No, it's not because the air is cleaner. It's because you can see more of Earth's curved surface. So as we go higher, the more of Earth's surface that we can see. So scientists have used the evidence you just explored to determine that Earth's surface is curved and its overall shape is spherical. Think about this evidence, then read and answer the question. Provide two pieces of evidence to support the claim the Earth is round. I actually wrote a whole master's thesis on this, so I love this question, but we'll boil it down to two different reasons why we know the Earth is round. So the first one is, as we increase our distance above Earth's surface, elevation, we can see more of the curvature. Additionally, boats sailing toward us seem to rise out of the ocean, travel across the curve. Anything along those lines would work. We're going to stop there for today. I'm going to try and keep these videos as short as possible. But if you have any questions, feel free to send me a Jupyter message. Stay healthy. And yeah, keep working hard.